be talking about how to build a search system, intelligent search system, but I'll split up in two parts in this. First, I'll just give the background of how do you build, what is the crux of the building a system, such system, and also later I'll just touch up on the one of the Watson service which helps you to build the search system. You don't need to build the background of the crux of that. It's already built. A knowledge base also will be there. But before that, I'll just show you what are the basics of such system. When you talk about an information system, right? Like it can be a text or the multiple documents what we will be having. When you say even the what you call even when you say standard database which you Oracle or anything, you want to search anything, we say that it has to be, if you want a better search, you say that the column should be indexed, right? You want to do faster. Similarly, when you talk about searching in a unstructured data, when you say searching unstructured data, it can be as just like keyword search what you do in Google, but that is not enough when you talk about the complete search system. The keyword search doesn't make much meaning. What you need to do is you have to build a system where it can understand your natural language queries. When I say natural language queries, it should be able to understand what entities or what information the user is looking. What information is looking, we'll have to see what are the entities present in these queries. Take those entities, then see the set of documents, which document has got the best. So that is how. Also on top of that, you will also find out if there are multiple documents, what is the best shoot in that. So you need, again, if you are not happy, you have options within services where you can train the system further. There are options how do you train the model later. I'll just touch up the later point, but just show here the basics. What I was trying to show here in this screen. Basically, I'm not so visible. It's like when you give information to the system, right? It tries to understand first what it should do is when I give as what you call when I say NLP, basic NLP, we talk about natural language processing, right? You try to understand what are the words and what are the meaning of that. So it's a sentence is okay, but if I talk about documents, right, multiple documents, first thing you have to do is you have to pick what are number of different words, unique words in that, right? Unique words, and then you should tell that this particular word has occurred in document 1, 3. This second word has occurred in document 5, 6. You have to get that posting. You're getting point, right? First, you try to understand what are the important words present in your system, that file system or what it can be any other system. Then you say that you try to map, you create a posting. When I say it's not visible, its first part is actually building a dictionary in the sense what are the words. Second part, posting, we call it as posting in the sense this particular keyword is occurred in these many documents. You get that mapping. But here when you say again, I just talk about machine learning, basics of machine learning. Here to build such system, one of the approach, there are multiple approaches. You can use other algorithms also. One of the approaches is called as bag of words. When you say bag of words, the name itself indicates when you throw documents to it, it just picks a bag of words of that. What are the words available in that? Okay. Now see when I say bag of words, what it does is it it picks all the words and converts to lower. Usually it's a standard process which you can do it. Converts to lowercase and have the array list of that words. And based on the words, then it helps you to classify the documents. When I say classify document in the sense, as I gave you the simple example. Now if I say that I want to look leave policy. If I'm doing a search system for within the organization, if I say I want to know about my leave policy in the organization, then it goes to your organization system. It picks the HR policy document which are related to HR policy. So that is just classifying the document which is related to HR. So as I said, this model is very simple. Just it has to just create a set of words what is required and what are the frequency. When I say count means how many times a word has occurred. Based on that you have the weightage for that. Again, there are systems whether like what you call internally you will be having any system you talk about. It has got stop words. You don't need to focus on the stop words. Stop words in the sense like if you have like is, as, was, right? You don't need to focus. There's not much importance information present in that words. So you can eliminate that words. Okay. Then there are three within if you use open source, right? scikit-learn, you have three options here. The three steps what you do is first tokenize the strings. When I say before tokenize string also I will say that when your document is given, it splits up the sentence into your token of strings. Then how many times the particular word has occurred, that means token has occurred in the document. then you normalize the weight. When I say normalize here is, why do you need to normalize? Now if I am referring to, if I just give example, if I am referring any documents within the organization, I am from IBM, if I am referring any documents, IBM is most of the times repeated in the documents, almost all documents, right? Since it's within organization I am looking out. Now that word may be occurring many times, but that is not important. If I am looking for HR policy, I look for HR is important for me, not the word which so that way, if a particular word is occurring more number of times, it doesn't mean that has to be given more weightage. You getting my point, right? If a particular word is occurring more number, it is not, that is not important for me. How do you overcome that one? How do you try to normalize that one? There are different approaches. You try to get a distance, then you try to normalize using some formula, so that other words also gets importance. I'll just show you that sample. You will find a particular word like 27 times if it's occurring more number of times. If what you do is, now see the word, if I take, there are different approaches. I can say number of tokens, what is based on number of tokens. So if I don't want number of times the token has occurred, I can use the equivalent length, which is to normalize your vectors. Basically what it does is, after you calculate weightage, instead of 27, the weightage can go here based on the calculation. Just already have a calculation here. Okay, it comes, you can apply instead of that weightage, you can use normalized one based on the using equivalent formula. There are different formulas, as I said. You can use any formula. So that's, you can normalize number of times the token has occurred. And it also, it's not only this one, like see if I have one document which is 3 pages, other document is 100 pages. When I say 3 pages, the number of tokens occurs in that document is less. If it's 100 page document, the token is more number of times that is occurred. Doesn't mean that document which has got 3 pages is less relevant, right? It doesn't mean that. It can be having important information. How do you overcome? This is the formula where you just apply. You try to normalize based on the length. Okay. Then we talk about sparsity. Basically, in the sense here, when you train a model, it's any machine learning model, not only text analytics or this whatever I am talking about. You train a model, you try to cover all the whatever index vocabulary, I mean words what you do. But when your person end user asks question, there may be words which is not present in this vocabulary. You getting my point, right? There are cases now you have 100 words. Have my vocabulary even I can have use a little bit in terms of million. I have millions of words in my vocabulary, but when the user asks the query, that words are not present, right? And most of the words which are there in the vocabulary is not present. So what happens in the vector space? What happens? Most of them there are zeros. You talk any model, most of them it is 0. So how do you handle that sparsity? So you have a library for that. You can within SciPy you can use that library. Okay, that's some about basics. Then I'll just talk about what are 2-3 different types of what you call APIs available within okay, in this open source Skylit. There are 2-3 parts. One, we have counter vectorizer. Then we have the transformer, what you call TF-ID transformer, TF-ID vectorizer. The other one is the hashing vector. Okay, these are different way you use it. Each has got its strength and weakness. In this one, it is just name as itself. It indicates count. Count vectorization is based on number of times the token has occurred. It is giving the weightage for that particular. It's just as the name itself indicates. It's just count here. What it does is it converts to all the lowercase to all the words to the lowercase. It makes the vocabulary out of that, and it, as you said, if it's a fit, means basically fit is nothing but it creates a vocabulary. When you say transform, actually it makes indexing of the documents. Okay, this simple step, as I said, you just say vector fit, then you say vector dot transform, and you can just specify what stop you want to remove the stop words from the English. Okay, then this is very important one. If I just spend some time on this TF-ID vectorizer. Here there are 2 parts in that. One is you take the count. After counting, you try to transform it. When I say transform it here in the sense here, you have options like the 2 terminals within this here. Earlier it was just that I said number of tokens. We had 2 terminals. This is called turn frequency. Other one is IDF, inverse document frequency. Turn frequency is number of again the number of times the token is occurred, but there is not just blank number of times. Use a formula log of use a formula and get the turn frequency. Other one is inverse document frequency. As I said, if the document is very big and if you should not give the importance just based on the length of the document or the number of times, use inverse document frequency, which will help you to overcome the shortcomings of the previous approach. I'll just show the code also for that. I'll just show you the code for that. Okay. So this is how the given word appears within document, and this downscales the word that appear a lot across documents, as I said. This is just work. This is again one third one, but it's only thing, instead of using the word, it tries to hash the words and try to use it. But problem with this one is it doesn't. If you have once you have the hash key, you cannot convert the hash key back to words. You're getting right? You generate a hash key out of the words, but you can't convert back to words after using the hash key. So that's a shortcome. Only thing is that memory usage wise, it's better. I'll come to this part later. Watson discover. I'll just show you the code. So this was one which I was mentioning here. So I have a few sentences. These are set of documents. See, if you look at this array list, just array list. Now each one is like how you had 4 sentences here. Assume that there are 4 documents. Now, if I run this code here, right, I get what all the features are available. Each word is a feature here. Okay. Now, what are the words? If you look at the vocabulary size, what is built here? Its size is 10. That means 10 words out of 4 documents or 4 sentences. What is provided? It has picked all the unique words, and it has created a vocabulary out of that. Now, when you say here, right, if you look at here, you have the one which I used was n-gram as single word. If I make, instead of feature, each word is a feature for me. Instead of one word, if I want to say 2 words as my feature, number of gram, I was for n-gram. If I use number of words 2 as a feature, then the size of the vocabulary increases, because see, as a big player, it repeats, right? Every word it goes on. So these are required. Why do you need this kind of stuff? Okay, just zoom it here. So why do you need a couple of words instead of single word feature? Why do you need 2 words or 3 words feature? Basically, there are different approaches. If you have more number of features, it's good. But again, it's again as you know, any machine learning model, overfitting and underfitting, right? That also you'll have to look at. Here, if you have more number of features, when you use 2 words, it becomes more meaning. You can make better meaning out of that. That's why you can use n-grams stuff. Along with that, when I just touched about only the words, bag of words, but here minimum document frequency. This basically what it means here is minimum document frequencies. If you want to, when you're developing a model, right? When you're developing a model, you can say that, okay, I consider the words or the feature. When I say word is feature here, I consider the feature only which is meeting this requirement, this threshold. Here I have I say minimum DF means document frequency, minimum number of documents which has occurred. So here I put threshold as minimum document frequency as 0.6, means 60% of the it should appear, at least 66% it should appear. So only the one in this sentence what I gave above, in this sentence what I is a sample here, it just picks up which is occurring minimum 66% here. So that means in this word only the park is picked because it is meeting the threshold. Similarly, like minimum document frequency, you have the maximum document frequency. Or like as I said, IDF, like similar to that, you can tell that only the maximum, this is a document frequency, it should occur. Only this many documents it should occur. More than that, you just remove. If it's repeating in many documents, you omit that word, because it means that it's not so important. Okay, so that's about counter vectorizer. The other one which this one most of times gets more attention here. This is TF-ID vectorizer. Here, as I said, formula, I have just written the formula here. When I say term vectorizer, this is the formula. It is term frequency into the inverse document frequency. The calculation of term frequency is just simple. You just calculate using the log stuff. Okay, but IDF, if you look at here, in this example, I'm having the 3 sentences here, 3 sentences. Now I just pick the document, number of documents is 3. Each term, this particular term is occurring in 2 documents. Is because, see, if I just it's occurred here, it is occurred here, two places. So the document frequency for this particular term is 2. I'm just touching only one term. Now based on that you calculate IDF, you calculate the IDF and you get the value. Okay. The reason why I'm just trying to this formula is you try to overcome the number of overcome the words which is trying to influence just by occurring more number of times. That's the intention of using IDF. Or if it's occurring multiple documents, you try to overcome that. You want to reduce that one impact on your model. Okay. See, if, just touch last point here. See the word 1 2 here is not as occurred more number of times. Not as occurred in 3 documents. So that what you call IDF for that is reduced. You just got 1. The word which is occurring only once. If you look at one document, if this word has occurred only one document, this is getting high priority. So because of that, this the IDF for that is more. Okay, this is just simple formula. So this is how the your what you call the search system works in the background. Okay, this is about the background, but I'll just give the now the important point about instead of doing this one as a developer. As a developer, if you you are focusing on developing quickly your search system, you don't need to write that code or all stuff there. There is one options available, one service called Watson Discovery. It's called Watson Discovery. It is a ready-made intelligent search system. Only what you should do is you don't. I mean, as I said, you just need to ingest your documents. This is Watson Discovery. Here, there are the different process. You just need to ingest your document what is present. Then you ingest the document gets indexed. You will be having the options for where you can later once a document is indexed. If you want, in case if you want before indexing, if you want to normalize the again documents in the sense here, if you are ingesting a HTML document, if you say that particular tag like the tag which the information which is present in H1 tag, H2 tag, or it can be script tag. If you don't need that information, you can just exclude that information which is present in the particular tag. You can clean the data before you ingest into the what you call discovery. It gets once you have done the indexing. I mean, when you done the indexing, then you can use query API. When you say query API, you can use there are two options in how do you query the discovery. One, you can use discovery syntax language, which basically discovery gives you the output in the form of JSON. As a programmer, if you know that I have to traverse this particular JSON structure within that, like no, what parent child, I can use that syntax. Or else the best option for end user is not about the what do you call that kind of programming. He likes to write natural language query. What we are talking about is such system. We say that I can't ask programmer to, I mean, end user to know the JSON structure, right? We will write to natural language. Simple. I want to know HR policy. That's how he can write. He will not know the JSON structure. So in that case also you can write natural language query. The system will go and pick the right document from that. I will just show you one sample also for that. So there are two parts. You ingest the document. Before ingesting, if you want, you can normalize. Then the query API is there. Again in the querying, you have options like we call it as I think expansion. What we call that? You see, wherever word has occurred now, I can say that OSI. I can search that. I want to know the information of OSI, or OSI can be also open source India, right? I can have an expansion list. Expansion list in the sense this particular term it has equivalent meaning, equivalent terms also. I can provide a set of words for that, right? I can call IBM. I can call that similar. I can call India or Hindustan or Bharat. Any term if you occur, you want to search for that. You can define telling that these are the equivalent terms for that. I'll just show you one sample here. This was the cases where we have used one of the case procurement case use case. What we do is we are using discovery with the JNS graph. Whatever documents, like if I want to procure any particular material, right? The information is spread in multiple documents. It can be website also. It can be website. It can be in database. It can be in PDF documents, in HTML files. The information is present spread across. Now, if I go to a procurement expert, he will go through all these sources. He'll build that intelligence, and he'll tell me this material you can purchase from this XYZ companies or XYZ client. then then you can go and collect that, or you can get the information. But you are dependent on the expert, and expert is dependent on the various sources. For expert to go through the 100 documents and coming up with the decision is a time consuming. You're getting my point, right? For expert, he has to go through various sources. As I said, it's different sources. It can be website, database, or any documents. He has to go through that. Instead of that, if you have a Watson discovery or anything similar to that system which has got information already, so what you can do, expert can, I'm not saying replacing the expert, but what I'm saying, expert can use that one. Okay, expert can go to that system and ask, okay, what are the information? Then the system will give for this material, these are the suppliers. These suppliers have the manufacturing unit of this capacity, but in case if that particular unit is under maintenance, it should be highlighting that, okay, though the supplier has manufacturing unit, but that unit is under maintenance. It can be under maintenance. It can be a transportation issue. It can be something like floods, whatever negative information is there about that particular getting material from that particular supplier, that should be highlighted. You're getting my point, right? So what we do is we build a system, and instead of showing a text output, we use a JNS graph and say that, okay, for this material, these are all suppliers, but in this case there is a red. Red indicates that there is something wrong with it can be under maintenance, or it can be some political issue or any climate issues. I'll just show you one sample here. See, as I said here, you have you can use discovery language, build the rules here, or else you can just type a question here. I just use. So I have the collection. The information is there. Already I have the collection here. It's a natural language, what usually end user asks. Now what I got is, this is the information from the documents which is collected. I'm using there are options within the result, whether you want passage level or whether you want at the document level. So I use a passage level. I'm getting the passages only. If instead of that passage, if I say only documents I want to see, but document is not a valid one. It just tells that which all documents it is present. So it says that, so these many documents you have the information, okay, for this query. I did not write any syntax, right? This is natural language query what I wrote. So I said that if I want only passages, I don't want, if it is 100-page document, I should go and read that again, right? It's 100-page document, I have to go and read. Instead of that, I want to pinpoint to the right answer. See, it will get the right answer. In this case, this is one option. In case if you are not happy with the the results, there is option to train your Watson again further. With that, you have to tell that for this particular query, this is a set of relevant documents. For this query, this is the relevant documents. That is how you have to do it. Okay, you have options again in the output. You can specify what columns or what outputs you want to see instead of complete result, right? Instead of complete JSON output, you can filter that just as any stuff, right? So I'm done with my stuff. I think just if you have any queries are there.
Actually, what is the difference between Lusny algorithm already is the same things, right? What's the improvement from this?
Yeah, I expecting that question actually. Okay, so you have if you talk about any such system, you have different set of algorithms. That's, as I said, based on your need, you build it. Now Google does most of the keyword search. There are other cases where if you talk about pharmaceuticals, right? If I talk about pharmaceuticals, if I say a particular compound, right, it appears in millions of medicines. I can't do keyword search there, right? So then your system with keyword search will not work out. So you need to build a system which can understand, as I said, entity information what user is asking for, intents. Even if I take simple chatbot, right? If I ask some queries on chatbot, it should understand important entities. How do you build that? There are algorithms. I'm not saying algorithm, but one is algorithm. What shoots, how well you use it, algorithm. Second thing is that what is your knowledge base here in the discovery? I did not get the time here. In the discovery, you have this. See, this I have not trained it here. This, okay, I did not train it. It has got knowledge base which can understand basic entities. It can understand pick the entity. If I tell that Bangalore, right, it knows it's the name of the city. It's an entity,
Okay.
location entity. If I talk about India, it knows it's a country entity. So that information is built in knowledge base. This is one, I'm just giving one use case. See, you can, as I said, you can crawl website using discovery, you can scroll database, you can crawl your documents. If you talk about basic things, you don't get the ready-made things there, right? As a developer, you have to build that on that an ecosystem.
Yes, again we can use on top of it in Elasticsearch.
Yeah.
We may add the mapping appropriate documentation.
Yes.
And put it whatever you said that the crawl we can get that crawl data from various system and then put it in big data, whatever's in big data we can store it and then again we can convert into index store, right?
Yeah, I see. Before discovery came, there was one of the IBM stuff only, retrieve and rank. It's basically, it was using Elasticsearch only, retrieve and rank. But thing is that if you look at advancement, as I said, we don't say that I just want this, where all this is, in which document it is present, my answer is present. We want fine tune to passage level. Again in the passage level, again we try to say that, okay, is there option to find further training it? See, before that it was retrieve and rank only. Retrieve and rank only, as you said, it was based on Elasticsearch. But that doesn't, what happens is, as the customer demand grows, you need to come up with better. Right, as I said, see they have different, as I said, see within what you call any algorithm you talk about, logistic, linear, anything, there are multiple algorithms, people have different, they use different algorithms, right, based on their need. But based on experience, customer experience, what you get, you have to evolve around that, right? We are using, as I said, retrieve and rank, which was basically Elasticsearch in the background, but that was not enough. Then that retrieve and rank got deprecated and we came with the discovery. This is further improvement on top of that. I can only say at the high level. As I said, it's not about crawling website, improving your results. There is you can have the expansion, as I said, equivalence terms what you want to use. And as I said, you can there are other options which I can like filter options what you get it. You can give aggregated search.
PageRank algorithm gives higher weightage if the page has
Visited more,
if the occurrence of the word is more number of times. But you mentioned about something called normalization.
Yeah.
That seems to be opposite of what the PageRank is. Can you explain that?
That's what I said. Right. Now, if I have two documents, I'll just take very simple use case. I have two documents. One document is 3 page, other document is 100 page. Yeah. Okay. Now, both are related to OSI. I'll take a OSI. When you say 100 page, number of times OSI has occurred is more in 100 page.
Yeah.
Obviously. Now, but my answer sits in the document which is in 3 page.
Okay.
You're getting my point, right? Now, how you normalize that? So you should. That's why I said you have to normalize. It's not the number of pages. You need information what you need. Okay.
Or PHP or Python.
Yes.
So do you have libraries available?
Yes.
Like, for example, Elasticsearch has got Java client libraries which I can use to access the Elasticsearch data from within my Java application.
Yes.
So
Yeah. Similarly, Watson API, it's a RESTful service. It's just a RESTful service. You can call in Java. You have the SDK for. You can call in Java. You have in Python. You have in Node.js also. There are four languages already have the SDK. You have SDK for that. So I can. This is where I just show you. I can just show here. So you just need to install Watson Developer Cloud. When I'm just giving the Python. Same thing is with Java also. Okay. There are options with the API where you can create the instance. You can for your environment collections. All program it. You have API for that. Everything for querying purpose also. You can add document, delete document through API.
Okay. Thank you very much, Mr. Rajesh Gudikoti. Please give him a big round of applause.